use parentheses. I know some of my students like straight lines. Well, if you're compulsive, go for your straight lines. I don't care. But in the first set of parentheses, you want to put what makes this problem unique. And so we have 0.248. Is it, wait, 234, excuse me. 2, 3, 4, and that is milligrams. Now, a number just hanging out by itself, if you have any trouble about tops, bottoms, numerators, denominators, you can always put that number over a 1. This is the number that's going to dictate sig figs in our answer. Okay, and when you're doing metric conversions, you never lose digits. Okay, now, your conversion factors, every conversion factor we use, do not let them dictate your sig figs. Okay, we're going to assume, this isn't always correct, but we're going to assume that those conversion factors are absolute numbers. You know, like there are 12 eggs in a dozen. Okay, it's not 13, it's not 12 and a half. It's exactly 12 in a dozen. That's an absolute value with an infinite number of sig figs. So what's going to dictate sig figs is going to sit right here in this first part. How many sigs does this guy have? Anybody? Shout it out. 3. Non-zero digits always count. Leading zeros never count. You just use 2 of the rules. So here, my plan is I'm going to go milligrams to grams, and I'm going to stop there. And then we'll move on to kilograms. Okay, I need a conversion factor. Okay, I had a conversion factor up here. 1,000 milligrams is 1 gram. And I had the inverse of that. Which would be appropriate to use here, this or the inverse? The inverse. And the down and dirty way to tell that, you want milligrams to cancel out. How can you get them to cancel out? They got to be on the bottom. So milligrams and milligrams cancel. We're looking for grams, and that's going to give it to us. Okay, now, if you have to do this on your calculator, you're going to be multiplying the numerators across, multiply the denominators across, and divide the bottom into the top. Order of operation on good calculators is sometimes problematic. So, if we stop right here, now I know the unit is grams. I want the number, the answer, in regular notation. I do not want exponential notation right at this time. So, Sarah, you have it.
234.
Okay.
What are we doing?
Okay.
Go the other way.
Go ahead.
0.000234.
Yes. Okay, a really small number. Well, that's such a small number, I might think it would be handier if I put that in exponential notation. And notice, these are 2 independent operations. First, Sarah gave us our answer here. Okay, but I think scientific notation would be better, so I'm going to say 2.34 times 10 to the Antonio. Give me a number.
-4.
Minus 4 grams. And you'll say, which way will it be on the test? It can be either way. Become versatile. Okay? Which way is it on your calculator? Your calculator has a mind of its own. Sometimes it goes one way, sometimes it goes the other. So we got to grams. Are you okay on that? Now, let's go on. If we survive this, then I'm going to erase this. Everybody okay so far? Did I hear a wait? Okay. What if we want to do right on to kilograms? We'll just keep this baby running. We don't have to stop in the middle. Okay, now let's think what we had. We had a conversion factor. There's 1,000 grams in 1 kilogram. That was our conversion factor because we did that translation of what kilo means. Okay, I got that one, and I also have the inverse of that one. Jeanette, which should I use? This one or the inverse?
The inverse.
The inverse, okay, so I've got 1 kilogram over 1,000 grams. And here's how you check her work. We want grams to cancel, grams on the top, grams on the bottom. What's left standing? Kilograms, and that's what they ask us for. So you're going to have this times 1 times 1, you get 0.234, and then divide it by 1,000, divide it by 1,000 again. There's several different order of operations that will work. Just be careful. A lot of people are rusty with that kind of stuff. Okay, now let's have, as our answer, I want to have regular notation first, and then we'll switch. So Emily, what'd you get regular notation?
0.000023.
How many zeros?
6.
6, 2, 3, 4. And the units are what, Emily? Kilograms. Is that what everybody got okay? All right, now, I don't like it that way. Just my decision. I don't like writing those zeros. I could have written the wrong number. Times 10 to the, now it's still going to be kilograms. Christy, what's that going to be?
7.
7?
Or negative 7.
Minus 7. Okay, 1, 2, 3, 4, 5, 6, 7. Yeah, minus 7. Remember, if it's a small number, it's going to be negative if you're moving to the right. Everybody okay on this metric? No sweat? Okay, let me show you then a wonderful trick if you haven't seen it before. If you are doing metric, the trick works. If you're doing metric English or any English business, the trick doesn't work. If you can write this, you can do anything. Let me write it and then I'll try to explain it. What this really stands for, of course it doesn't spell a word or anything, it stands for just about any prefix you would ever want to know. You don't need to write this down, but let me just run through it this one time. Now here they're using capital K, chemists are not always consistent, and that means kilo or 1,000. H stands for hecto. Hecto means 100, but it's seldom used. Capital D stands for deca. Means 10, like decade. What's a decade? 10 years. Then the basic unit, and if you're talking masses, the basic unit is the gram here. Then this stands for deci, D-E-C-I, and it means a tenth. About the only people that I know that use deci are hospital people. You know, when they talk about your cholesterol, they usually talk about it so much per deciliter of blood, and that means a tenth of a liter of blood. Weird units. Medical people do some strange things. So they choose deciliters. But the reason for that is because, not because we've argued with them over the years, it's because years ago, as medicine was developing and as science was developing, we were on different sides of the universities. There were not computers to have this instant communication with each other. So medicine grew up one place, science grew up someplace else. That's why even country to country we didn't communicate. So that's why you get a lot of things that are hard to understand. So they use cc, we use milliliter, just because we weren't communicating. Okay.